Prior to performing an indoor air sampling event, it's important to search the sampling area for potential background sources of volatile chemicals. Household cleaners, lubricants, and other products, such as those commonly stored beneath kitchen sinks, may contain such chemicals. Here you can see our vapor intrusion specialists checking container labels for brand name and other identifiers, which will be compared to material safety data sheets for their contents. A field screening instrument is also being used to check the ambient air for the presence of isolated background sources. Indoor air samples are typically collected using a stainless steel vacuum canister, which has been pre-cleaned by an analytical laboratory and delivered to the sampler with an internal negative pressure. The sampler is equipped with a regulator that allows a sample to be drawn into the canister slowly over a predetermined lapse of time. Indoor air samples are usually collected over a 24-hour or 8-hour time frame. After setup, the sampling canister is left in place and normal activities in the area can continue. After the sample collection period has elapsed, our vapor intrusion specialist returns to retrieve the canister, which now contains the ambient air sample. Care is taken to record all starting and ending internal canister pressure readings, sample identification information, and any other noteworthy details of the sampling event. The sampling canister is then disassembled, placed back into its shipping carton, logged onto a chain of custody form, and returned to the laboratory for analysis of chemicals of concern. In addition to the collection of indoor air samples during vapor intrusion assessments, it is often necessary to collect samples of vapor from beneath a structure's floor. While this process is fairly non-invasive, a place must be chosen where a small sub-slab vapor sampling port can be installed. Once the structure's owner agrees upon the chosen location, our vapor intrusion specialists are careful to take note of pre-sampling conditions in the space so that it can be recreated after sampling activities are complete. Care is also taken to ensure that no unanticipated damage occurs during the installation of the vapor sampling port. Enviroforensics often conducts vapor intrusion assessments in privately owned homes. Because of this, we take the necessary precautions to minimize the intrusion. In order to efficiently and quickly install the necessary sub-slab vapor sampling port, a small diameter rotary impact hammer is used to drill a hole through the concrete floor of the structure. Dust created by the drilling is carefully swept away and collected. Several types of ports are commercially available that can be installed to allow for the collection of sub-slab vapor samples during these vapor intrusion assessments. Oftentimes, sampling technicians build these sampling ports themselves using parts and fittings purchased from hardware stores. Recent industry advances, however, have allowed our vapor intrusion specialists to quickly install high-quality sampling ports without the need for messy concrete or sealing materials. These fabricated sampling ports also provide a high-integrity seal between the port and the concrete floor, which is necessary to ensure the quality of the sample being collected. Sub-slab vapor sampling guidelines in most states require that leak tests be conducted at every sub-slab vapor sampling probe prior to or while taking a sample. A leak may allow ambient air into the sampling train, thus diluting the vapor sample and underestimating the results. In order to ensure the highest quality data for sub-slab vapor measurements, leak checks are often performed by exposing the potential leak sites to a known compound during sample collection. The compound is then analyzed in the field as shown here, or in the laboratory to determine if the sample was compromised by ambient air intrusion during sample collection. A wide array of leak check compounds are used during sub-slab vapor sampling investigations. Shown here is a canister of helium gas, which is one of the most widely used leak detection gases. A specially designed shroud is placed over the sampling port and the helium gas is introduced. Sub-slab vapor is purged from the newly installed port beneath the shroud. If a leak exists, the helium tracer will be present in the purged sample and will be measured by the helium detector. If no leak is detected, then the seal of the sub-slab vapor sampling port is considered intact and preparation for sample collection begins. Sub-slab vapor samples are collected utilizing negative pressurized stainless steel canisters, just as are indoor air samples. The sampling port is connected to the sample canister using new Teflon tubing and new decontaminated fittings to ensure that the sample collected is representative of actual sub-slab vapor conditions. Additional leak testing is conducted of the sample tubing and fittings to make sure that no ambient air enters the sampling train, thereby causing dilution and drawing the sampling results into question, as previously discussed. This is performed using a series of valves and a handheld vacuum pump, which is used to create a negative pressure as high as 60 pounds per square inch within the tubing. Once this negative pressure is sustained within the tubing for at least 1 minute, the sampling train is considered leak-free and sampling can commence. The collection of a sub-slab vapor sample can be performed as quickly as within a few minutes' time, or as a time-weighted sample over a period of 8 hours or 24 hours, as with indoor air samples. Although sub-slab vapor sampling ports may be left in place after sampling to facilitate future events, it may be preferred to remove the port immediately following sampling. The structure's owner is often consulted while making this decision. Our vapor intrusion specialists will carefully repair the resulting hole in the floor with a strong, non-shrinkable concrete product so that the integrity of the slab remains intact. The carpet or floor covering is repaired, and the room furnishings are replaced to match the pre-sampling conditions. The Enviroforensics Vapor Intrusion Assessment Team of scientists and professionals are committed to data quality excellence while remaining sensitive to community and stakeholder concerns.